Okay, so as we talked about before, large language models, foundation models, this is where we start to see AI reach its maximal set of capabilities. And so it's important to understand how we're going to train these models moving forward, particularly in these decentralized settings. And so in the last 12 months, we've seen, as I mentioned earlier, between 100 and 1,000-fold drop in the amount of communications and synchronizations required for training to occur. This has profound repercussions in terms of the algorithmic needs of training these models. And I think today there is mounting evidence in startups, evidence in academics' labs, even evidence in big tech, that perhaps the workhorse of data centers, this distributed data parallelism paradigm of training these models, is going to give way to federated versions that allow us to have these GPUs placed in different locations. And if that ends up taking place, if it does turn out that DDP can be replaced with different federated learning algorithms, not only between GPUs, but even inside data centers, that will radically change how we train these models. It'll also radically change even how we architect these data centers in the first place. And so this is a dramatic change. If it does come to pass, we won't be saying that DDP is being replaced by federated. It's very likely that we're saying that Flower has replaced DDP. Let's dive into one of these results to give this a bit more color. And so this is a result that we put up around November last year, and it just gives you more context to what we're talking about. Here we demonstrated that you can train a 7 billion parameter LLM. We compared it to DDP. We looked at it when we normalized the actual communication speed, and when we did that, we found that federated learning and variations thereof were able to train that model, train it to convergence, have a very strong model, and yet it would actually only require, you would actually reduce the amount of communication and synchronization required by a factor of 1,000. You can see the details here. You can see that communication time for the flower photon combination that allows this to be possible is actually has a huge drop in the amount of communication time required. And so this starts to open the door dramatically to different variations of AI infrastructure that now becomes possible. As I mentioned before, we can start to see data centers themselves starting to change. There's no need necessarily, potentially, to have so much network infrastructure between these GPUs. It also opens the door to networking between data centers. We already start to see this emerge, but that type of networks will be far more efficient when they can start to adopt algorithms of this kind. It starts to also make it possible to democratize networks of robots and cars and other devices that fundamentally need to be trained in a distributed way. If you think about when you want to train a foundation model for embodied AI, you really don't want to centralize this, particularly because the data involved is so dynamic. The world's a dynamic place, and you don't want to have to copy all the data from a car into one place to train a perception model. We see these things being possible in only a few of the companies right now, but once we've started to make these breakthroughs in distributed training, they can become much more commonplace. This last one here I want to point out is that we can start to see a lot more collaboration between individuals. In the room right now, we have a dramatically, powerful local machine that's able to stand up the largest, best open source model around, at least currently, DeepSeek, and it runs on a single computer. You don't have to network multiple computers together. You can have a single computer and it just runs. When you have that possible, combined with the breakthroughs in distributed training I'm talking about, suddenly individuals can start to work together towards serious types of models. Similarly, we can have companies, this last example here, we can have large Fortune 500 companies that are currently outside of the AI game, working together, sharing resources, potentially individual companies might not have enough resources to stand up one of these huge models, but by working together and also leveraging the data they uniquely have, so like folks like McDonald's, Starbucks. These are not tiny companies by any means, but they're not training models in this sort of giant fashion right now. But they can soon start to work together, use the data that they uniquely have. We would hope they'll do this so safely in order to build models that have unique capabilities. And again, all of this is possible through this breakthrough in distributed, decentralized training. So, in order to make this possible, we have radically added to the Flower ecosystem and platform in a number of ways. And so we've done a lot of research and collaboration with folks at the University of Cambridge, and we've developed the missing components of a stack that you would need to be able to build systems of this kind. What's important is that these components are open source. They have been peer-reviewed. So, for example, key parts of the stack, such as really interesting ways of coming up with embeddings that you use when you're training federated models in order to have low memory, in order to have high perplexity, or better perplexity, is only possible through some of the designs that we've come up with and have had it peer-reviewed. And so, for example, this embeddings work is an oral at iClear and was actually ranked 28th out of 11,000 submissions to iClear. People felt it was that impactful, that interesting, and so in a few months' time, you'll be able to see it done there. Similarly, the Photon system, the system that orchestrates a lot of this work and sits on top of Flower, again, this was a collaborative work, and it was published to be appeared in MLSys. And so my point here is that this framework is ready to build these next-generation AI infrastructure. The open sourceness and the peer-reviewedness are systems that you can then start to build with a great degree of certainty. So let me just start to tell you a little bit about what are the main milestones that we've reached in the last 12 months that are going to really be able to start to make these systems become more stronger and impactful. So there's this issue of SOTA. It's no good training these models if they lag behind what's state of the art. If I can train a decentralized LLM, but it's never able to be as powerful and as accurate as the ones trained centrally, then interest in that type of model might start to wane. So as achieving SOTA was something we definitely wanted to see be possible. To see where we are with this, you can see a number of existing decentralized models that have been trained over the last 12 months. They range in size between 1 and 15 billion parameters. And what this figure shows us is how far behind the centralized versions they happen to be. And so you can see, for example, in some cases, models are 25% behind. This is on downstream tasks. In other cases, they're 5% behind. But the point here is that they're lagging. And so we're very interested in being able to achieve SOTA, and I'm glad to announce that we've been able to do it through the use of depth embeddings, through the use of a new optimizer that we'll be announcing later in the year, through the use of a important networking stack, and using Photon. We can now train, we believe, of an arbitrary size SOTA-level models as long as we have enough data and compute. Our demonstrator for this is called FlowerLLM 1.7b. And you can see here, it might be a little bit hard to see on the screen here, but if I zoom in a bit, you can see that it narrowly matches the SOTA level of performance for that particular model size, which we align to be the small model coming from Hugging Face. So this is a big breakthrough because this is a SOTA-capable model that was trained decentrally. And so you'll not be able to find this with any other type of model sizes out there that have been trained in this fashion before. If I show you this illustrative convergence figure, I can start to point out that what we find when we put this recipe together of these various components and we start to train in this decentralized fashion, that initially the centralized version wins. And so as we train further and further and the system starts to tune, we can find convergence eventually that matches, or in some cases slightly beats, in some of the downstream tasks that of a centralized model. This is exactly what you want to see possible, and if I showed you the loss curves of other types of decentralized models, they wouldn't look quite as nice as this one. We believe that these techniques should hold up, in our estimation, up to 100 billion parameters, and so that we're looking for partners to work with to demonstrate that this is actually the case. And so that is Flower FlowerLLM 1.7b. This is the world's first SOTA LLM, meaning that it's a LLM that's achieved a SOTA level of performance, and it's unique in the fact that we actually trained this in a decentralized method and manner. So what's next? I mean, if we can train SOTA models in this fashion, if it's so important in the way that I'm talking about, well, then we really need to start to achieve milestone 2, which is critical mass. And so I'm delighted to announce that we've managed to achieve a lot of what you'd want to see in terms of critical mass being achieved and planned in this direction. I can actually outline this in terms of 3 numbers that go from 1, 2, and 3. So what are these numbers? Well, the first is that we have our first government adoption. I'll explain in a minute. The second is that not only do we train foundation models now, we're actually having other organizations work with us to train their own foundation models. In some case, they don't need very much help from us at all in order for them to train their foundation models. And finally, 3, let me explain that in a second, because that actually doesn't stand for 3, but it stands for 1.3 million users that we're going to have access to in a partnership I'm about to describe in a few seconds. And so, one by one, we've actually had our first breakthrough in terms of governmental relations, of working with a government, working with members of governmental organizations who need this type of facility. And so I'd like to call out Sprint D as an important German-based government organization. They actually has given Flower money and a set of goals that we plan to be able to achieve. We're going to achieve these goals, and then we're going to have these things adopted all throughout Germany, because this is what the type of thing that you need when you're building foundation models. You need the ability to integrate all the data of a country. You need the ability for a country to build its own models in its own, with its own resources. And so we're delighted to be working with Sprint D on this aspiration. So they are our first country-level partnership that this technology has achieved. 2, the foundation models. We have been working with a number of organizations. Eden represents one of them. The other is based in the States. They're both interested in building AI-based foundation models and using federated-like methods. And so they've been using different parts of the Flower stack and having, dramatic success in building these models. They come from, UCL, Moorfields, Charlotte, North Carolina, and Stanford. They're independent groups. We give them, the amount of support they need to train their models, but largely they're building it on our open source efforts. And I can't be more enthused about the types of models they're building independent of us right now. Now 3, that is very exciting to us too. I'm going to end with 3. 1.3 million users at Varna. We actually have Anna, who is the creator of Varna, in the house right now. She's also the CEO of Open Data Labs. She'll be speaking next and probably to expand about where this 1.3 million comes from and where, importantly, it's going to next. But Flower is going to work very closely with Varna in the next 12 months. And this is towards a model that I mentioned earlier in the keynote, but that will change the face of AI. That's because it's going to be the world's first decentralized, user-owned foundation model. We're calling this Collective One, and that's because Varna is a specialist, perhaps the best organization in the world in helping people form DAOs that allow users to get their own data under their own control and then decide how they want to use it. And you can just imagine how important that is in terms of ecosystem building for the types of things that Flower and everyone in this room really wants to see happen. What we need to do now is, given that we can build models of this kind, we need to find sources of data. I cannot imagine a better partner to work with to provide us with this type of data that we can then start to build a foundation model where every person who contributes data naturally owns a piece of it. And there's a very clear pathway of where that data came from and them opting in, and then that model being able to be used for downstream tasks they care about. This is going to change the way AI is done. And so we're delighted to be doing this in the next 12 months with Varna. So I'm sure Anna is going to tell you more about this, but just to give you a sense, we're currently aiming for a 7 billion parameter model. We'll be working, moving through the different DAOs that are part of the Varna sort of ecosystem. What's important here is to know that the types of information these DAOs have are completely unlike the ones that you see in foundation models and LLMs today. Those types of LLMs, these conventional types of models, they contain data solely from the web, solely scraped off the internet. Some of the practices and collecting this data is somewhat questionable. In this setting, actually, our model will come from a variety of different sources, Reddit, LinkedIn, GPS data, IoT data, but the key thing is that every single piece of data will be associated with an individual who said, yes, I'm happy with this piece of data to be used for this model, and then we'll see just how far this model can fly when we start to give it access to data that it could be otherwise impossible for it to access. And so, to close, LLMs, foundation models, this is where we see just how far AI can go. They won't go very far, much longer, unless they're being trained in a decentralized manner, and Flower has the perfect set of technologies and stack in order to build these new emergent forms of training. We are delighted to be working with Varna with Collective One, which we think can be a blueprint for many foundation models that are built in the future. We're delighted to see things like FlowerLLM 1.7 demonstrating that SOTA is extremely achievable and must now be the norm moving forward for all decentralized models. And finally, and most important to me, I'm so happy to see the ecosystem of users expanding rapidly, including countries, including people with important types of societally relevant model building tasks, such as how do we detect different types of eye medical data, working with Flower to build these types of foundation models the world desperately needs. And so thank you very much for listening. I'm happy to hand over to Anna in a few minutes, but any one or two questions?